Okay, so here's the idea, everybody. Okay. You guys should be familiar with these two shapes. Have you seen them before?
Yeah.
They're both prisms, right? Does everybody know how to define what a prism is?
3D shape.
Well, yes, but there are many different kinds of three-dimensional shapes. Okay? Just checking to make sure my mic was on. All right, so there's many different kinds of 3D shapes. A prism is such because it has two bases. Okay? The bases are what it usually sits on. All right? So, notice in each case here, I highlighted one of the bases in red. Okay? So this is a rectangular prism because the base is a rectangle. All right? And the top's also a rectangle. And the other sides are flat surfaces. That's why this is called a prism. Okay? Likewise over here. Top and bottom are triangles. The other sides are flat surfaces. Okay? Those are why those are called prisms. All right? You guys remember the volume? How to find the volume of a rectangular prism? Many times width times height, right? What about for a triangular prism? Why is it different for a triangular prism?
Because the
Triangles have to square, right? Okay. But in either case, do you guys notice anything about this? Check this out for a second. Okay, hold on. I want to highlight something important here. Check this out. What's going on here with this piece right here? What's going on with that? You see it again right here. How about a hand in the air, please? Okay. What's going on with those two pieces? Charlie? That's the same way you get area, right? Area of what for the first shape? L times W is area of a, or more generally, a rectangle, right? Isn't the base a rectangle? So wouldn't that be considered the area of the base? Yeah. Okay. Doesn't that apply also to a triangular prism? Guess what? It applies to any prism. If you know the area of the base, then you just multiply that by the height, and you get the volume of your prism. So this now allows us to find the volume of non-traditional prisms. Maybe the base would be a pentagon, okay? Or the base might be an octagon, or a hexagon, or a heptagon, or a nonagon, okay? We can keep going and going and going. If we know the area of the base, all we have to do is multiply that number by the height, and we get the volume, okay? That's the little bit of a, probably a little bit of a new here for you. So, to generalize this formula, we don't always just put L times W times H anymore, okay? We do it for any kind of prism, or any kind of other shape that's similar to a prism, okay? So, I don't know if you've seen this volume formula before, okay? But this is the idea. Have you guys seen a volume formula like this before? Capital B is different from lowercase b, okay? Lowercase b is usually used for length, okay? Okay, so you might have ever seen that in the triangle formula 1/2 BH. That's the length of the base, okay? Or for a parallelogram, area equals base times height. Length of the base. Capital B is different. Capital B is the area of the base, okay? Does that make sense? So in this case, if I highlight this in red right here, then the red parts from those formulas above are the same values. So this would be capital B here, and this would be capital B here. Does that make sense? Okay? So by allowing us to rewrite that part of the formula but with just capital B, now I generalize the area part of the prism formula, and now I can find the volume of any prism. Okay? Now you're probably wondering why this is important, because I've already found the volume of prisms before, right? Well, in 8th grade, we don't find the volume of prisms. We find the volume of pyramids. Okay? And here's the thing. A pyramid is part of a prism. Okay? a pyramid is part of a prism. In fact, okay, a pyramid has one base, right? Has one. I'm going to show you a picture in just a minute so you can remember it. A pyramid has one base, and then all the other lateral sides meet at a common point above it, usually, right? It doesn't be above it, but usually it's above it when we see a picture of it, correct? Okay. But there's a common point there. It's called the apex, okay? And all the other common sides meet at that common point. So you only have one base on these. As it turns out, there is a really interesting relationship between the volume of a pyramid and the volume of a prism to have the same base. Okay? The pyramid's volume is only 1/3 of the prism's volume. That's why the volume formula for a pyramid is 1/3 times area of the base times height. Okay? Now, if we were doing this and if we had extra time, you guys would be experimenting with this. Okay? You guys would come up with this fraction here, 1/3, after some investigation and stuff like that. So I'm giving you this information free of charge today. All right. So all we can have to do is practice it and apply it. So I'm telling you that the volume of a pyramid is 1/3 times the area of the base times the height. Okay. So in our formula here, capital B means the what? Yep. And let's make sure we emphasize area here. That's important. Okay. So area of the base, right? And H again is the height of the pyramid. Okay. So has everybody got that a screenshot of that for their notes? Okay. Now I'm going to show you a picture of a pyramid, and a lot of you are probably going to say, "Oh yeah, I remember what those are now." Okay, and that's fine. All right. We're going to take you through a problem and give you a chance to probably work one more, and then we're going to go on to another shape. Sure. Based on other dimensions. All right. Are you guys ready to move on? Okay. So I have some examples here. I just hid the picture because when I usually do this, I don't want everybody to see the picture right away. We try to practice drawing the picture first. But for our purposes, I'm going to remove this square and it's going to show you the picture. Okay. So there's my picture. So go ahead and get a screen cap of this. Okay, so you don't have to go ahead and draw the picture. All right, I got a picture of it. Okay, so here's the deal. All right, we have to find the volume of this pyramid. All right, everybody good with that? All right, what do we know? Well, let's figure out our dimensions, shall we? What are the dimensions of this pyramid? Pyramid. Did I say period? I meant pyramid. What's the height? What's the height of this pyramid? Okay, Charlie? Height is 3 meters. Now here's the deal. When you are drawing the height in, you have to draw perpendicular to the base. Okay? So you might have noticed right here, okay? I'll highlight this also. But right here, you might see this right angle marked right here. Right? And then when we do right triangles. Okay? That means that this red line is perpendicular to this blue base. Okay? And I highlighted the base in blue. So we know what the dimensions of the base are. How big is the base? What are the dimensions, kids? 6 and 2, right? So is it a rectangle? Is it a square? What is it? It's a rectangle, right? Okay, so let me just emphasize this right here. That's a right angle, okay? So we know that's the height. So I'll put that in as 3 in a minute. What's the formula I need? Remember what the formula is? V equals what? 1/3 area of the base, right? You know what? I'm going to make that 1/3 different color just so we have some contrast here. 1/3 area of the base times the height. Okay? So, we know the height is 3, so I'll put this as 3 right here. Okay? The 1/3 is going to come down. Everybody okay with that? Now, what's the area of the base? What's the area of the base? What numbers go for the area of the base? It's a rectangle, so what's the area of the base? 12, right? 6 times 2. Everybody okay with that? You guys are quiet out there in math land. You guys okay with how I'm doing this? Yeah. So, ladies and gentlemen, all we're doing here is we're going to take the values given to us, we're going to plug them into a given formula. You get this formula on the test. So I'm not going to have to memorize this, okay? You get it. All you have to do is know where the numbers go in the formula. Put them in there, use the order of operations, and get the number you're looking for. That's all you have to do here, okay? So I'm actually going to write this, first of all, as 6 times 2 inside. And then on the next step, we'll write it out, okay? So it becomes 1/3, right? Times 12 times 3. Everybody good with that? Okay. Now, I like to multiply the integers together first, okay? What's 12 times 3? 12 times 3. 36. Very good. Okay. So we'll have 36. Okay. And so I'll have the 1/3, right? Now, this is 36 over 1. So again, we're just going to kind of play this out a little bit so you can see how this all works out. Multiply your fractions straight across. Okay. You end up getting 36 over 3, right? What's 36 over 3 become? 12. 12. Okay. Now, your units will be given to you on your test. Okay, you don't have to worry about your units. All right? So 12 what? Was it 12 meters? Meters cubed? Is that correct? Yeah. It's volume in 3 dimensions, right? There's your final answer, ladies and gentlemen. Are we okay with that one? Okay, great. So, can I review this real fast? Everything will be in good shape, right? All right, so from your picture, you have to identify what information given to you. You can reset that. Chris, thank you. Okay. Okay, so on the picture, all right, we were given the length and the width of the base. That's 6 and 2. We were given the height was 3. Okay. Area formula is area of the base times the height times a third. Or another way to say this is area of the base times height divided by 3. Okay. You can say it that way too if that makes it easier for you. Okay. Because the last thing we're going to do here is divide by 3, basically. Okay. Especially if this is in a perfect multiple of 3, it doesn't make it very nice. Okay. So I have 6 times 2 for my area of the base. That becomes 12. 12 times 3 is 36. Divided by 3, I get 12. Okay. So the math on here, I don't think this will be very difficult. It's going to be making sure you get the numbers in the right spots so you get the right answer. How are we doing? Okay with the first one here? You guys will need to practice tonight, okay? Or tomorrow. Let's try another one, and then we're going to move on to a different shape, I think, okay? So, sometimes you get something interesting happening here. So I'm going to take this one off, okay? This is interesting. Get a picture of it. Now, what shapes the base this time, ladies and gentlemen? It's a pentagon. Now, do you have to find the area of the base? Right? Do you have to find the area of the base, kids? No, it's given to you this time, right? So how is this different from the previous problem? That's what we have to figure out here. How is this one different from the previous problem? How about some hands in the air, guys, so we can talk about it? Okay, Evie? So instead of having to find the area of the base yourself like you did on the first problem, what do you have to do this time? Oh, I don't think so. Not this time. There's my formula, right? Doesn't this number just go in for B because that's what B equals? That's the difference, right? Okay. The difference is that sometimes you're going to have to find the area of the base before you can find the volume. Other times, the area of the base will be given to you free of charge. Okay. This is why you have to be careful and pay attention to detail. All right. Because sometimes I have students get mixed up when they're given the area of the base automatically and they'll have to find it because they think they're missing a dimension. They're not. Okay. I'm telling you, the area of that blue shaded part is 24 feet squared. All right. What do you do with that 24 to get the volume of the pyramid? What do you do with it? What do you multiply it by? By what? Besides 1/3, what else do you multiply it by? What's your height? Did you say height, Madeline? Did you say height? You said 5. I don't see it. It's not a 5. It's an 8. Okay. That's it. Were you trying to look at the red number though? Okay. Right. Okay. Are we good with that? Okay. You guys set it up and then try to work it out. And please use your calculators. Okay. Use your calculators. When you give an answer, share with your group mates. Make sure you guys are on the same page, okay? Your numbers and go to it. That's all you have to do here. All right. Go ahead and start comparing your numbers with each other, making sure you guys are on the same page, okay? I like what I'm seeing. Again, you got to show your work. These are with 2 points on the assessment. 1 point for the work, then you have to show your steps. 1 point for your correct answer, okay? Make sure you show your work. Let me see here. What you got? Okay. Back up. Okay. Back, scroll up just a little bit so I can see what the previous numbers. Okay. So remember your formula. Let's start with that. Okay. So like I wrote down here at the very bottom of your screen. Okay. Always start with step 1. Write down your formula. Okay. And then plug into it. So start with this one and then plug in your B. Plug it in right. But don't forget that 1/3 in front. Okay. Are you good with that? Yeah. You did it right. Just look again. Now I screwed up good. I would do those 2 first and then every time. Okay? Because it might not work out nicely. Well, we're about to find out. Okay? Everybody jump into group mates? Are you guys okay with this? All right, I'm going to start filling mine out here, okay? All right, are you guys with me on my work? So I plugged it in there. The base is 24, okay? And it's just 24. So it's 24 times 8. That's 192 because your height was 8, okay? And then you take 192, divide by 3, and you get 64. What's up, Lily? Okay, you're right. Remember how you get area, okay? If it was a rectangle, how do you get it? You get length times width, right? Okay, that's two dimensions being multiplied together. That's how you get the square for area, okay? We multiply by the third dimension, which is height. Then that's how you get a cube on your answer, all right? So I already told you the area was 24 feet squared. So when you multiply by the 8, you get cubic feet, okay? So it's 64 cubic feet. Does that make sense? Okay. So yeah, it is an area, so you're going to get that number as a squared, it's a unit squared value, not that the number's squared, that the units are squared. Okay, good question on that. All right, are we okay with that one? So just two different kinds of these, all right? Sometimes you might be given the area of the base flat out. Other times you might have the dimensions to find it, okay? And we're going to stay pretty basic on that, all right? I would suspect nothing more than squares and rectangles and triangles, all right? Otherwise, we'll give it to you, all right? We'll give you the area of the base, all right? We don't expect you have to know how to find the area of a hexagon or anything like that. That's not the importance here, okay? Are we good with that? So I think that's basically pyramids, guys, okay? Are we good with those two examples for pyramids? Okay, well, you know what? Let's talk about cones then for a minute, shall we? Monica, you got a question for me? Just hold that thought. Hold that thought, okay?
So you were saying cones?
All right. To be coming soon to a math class near you, as I say, okay? All right. What's a cone, guys? It is a thing.
It has a round bottom and it goes up and gets smaller.
Okay. So what would be the base of a cone? I guess I should say. What shape would be the base of a cone? Raise your hand. Amelia? A circle, right. Okay. So, ladies and gentlemen, think about this for a second. Okay? Let me get back up here just a minute. I don't want to give you too much information ahead of time. All right? How do you find the area of a circle? How do you find the area of a circle? I don't want circumference, I want area. That's what I wanted you to think about here. Okay. You know how to find the area of a circle? What value do you need? Up on the cabinet up there, Lily. You have to have pi in it because it's circular. Okay. Now, what do you multiply pi by to get the area? Okay, Charlie?
It's pi r squared.
It is pi r squared.
By the radius.
Pi times radius squared. That's how you get the area, right? Okay. Circumference is pi times diameter of 2 pi r. We're not worried about circumference. We want the area, right? Because guess what? Okay. If a prism has two flat surfaces for bases, guess what? Okay. What would you call a prism that has two circles for bases? A cylinder. Exactly. A cylinder is a prism with circular bases. That's all it is. Okay? So guess what? If a pyramid has only one flat base, then a cone is like a pyramid and it only has one base that is a circle. Yeah, exactly. So guess what? Okay? A cone is a special pyramid. Okay? So we know how the volume of a pyramid differs from the volume of a prism with the same base, right? It's only 1/3 of the volume. Guess what? That's why the cone formula has 1/3 in it too. Okay? And you know the area of the base because Charlie just told us that. Okay? So you just take the area of the base times the height times 1/3, and you've got the formula. 1/3 pi r squared h. Okay? Does that make sense, everyone? Yeah. So it's simple as that big general formula, 1/3 capital BH. Because capital B this time is pi r squared. Are we okay with that? So all we're doing here is just modifying our formula a little bit specifically for a cone. That's all we're doing, okay? So here's the formula right here. Okay? Remember this part right here? That's your capital B. Okay, so it's still following that same pyramid formula here that we have, okay? Everybody good with that? What's the R stand for? Radius of the base, right? And the height would be h, correct? Okay, now, I'm just going to throw this up there already. I'm sure this is going to come up. Oh, you know what? Let's just throw this up for a surprise. There could be a surprise coming up here pretty soon. Okay, you guys like surprises in math class?
No.
Oh, well, too bad. Okay. Oh, I'm sorry. No, this is a mathematical surprise. Okay, this is a mathematical surprise. Okay, you know me by now. I'm sneaky. All right, watch this. All right, you guys ready to try a couple of examples of this? I'll do the first one with you, kind of get you a lay of the land a little bit. You're just trying, it's the same thing you just did, it's just a different formula, okay? You're going to plug all the numbers in, and you're going to use your calculator and get the volume. That's all we're doing here, okay? All right, here's the first one. I'll remove the gray square. There it is, okay? If it helps, I can shade in, maybe I can shade in this base here. So you can see it here a little bit better, maybe. I don't know if that helps or not. Does that help a little bit? You can't draw as a circle completely because that makes it look a little bit, because you're looking at this from an angle. So it will not look circular, okay, and all the time, okay? All right. Are we ready to go here? Okay. So, do we have everything we need? Let's check, okay? What's the formula for the volume of a cone again? It is 1/3 pi r squared times the height, right? Do we have all the information we need? We need the radius, we need the height. Do we have the radius? Okay. This is a little other trick you can do sometimes, okay? We didn't do this with the pyramids, but you could do it with pyramids, all right? Actually, we kind of did with the last one, but we'll do this again with this one too. Sometimes you can just draw an arrow from your dimension on your picture to where it goes in your formula, okay? 6 is the radius, right? So you can draw draw an arrow to the R. We have that value, right? We're good. Do we have the height? We have h. Yep. Okay. We do. Okay. What's the height? Mary, what's the height? Very good. So I just draw a picture or draw an arrow there. We got everything we need. Plug them in. Okay, are we good with that? So this is just plug and go for the most part, guys, okay? We're not doing like anything major here. In fact, these really aren't algebra problems yet. Okay, they might become algebra problems next week a little bit. We might just graze the surface there just a little bit. Okay, no more. We might go even a little bit more in depth. We're not doing that this time. Okay. All right. So plug in. Here we go. Okay. We have 1/3 times pi. Leave the pi alone for a minute. We're going to talk about what to use for pi here. Okay. R squared. 6 squared. Okay. And the height is 15. Okay. Show me a thumbs up if you're okay before I put those numbers. Do you agree with what I just did? Excellent. Now, what should we do first? Think about your order of operations. Okay, raise your hand. What should we simplify first here? Somebody said it. Evie? The exponent. What's 6 squared? That's 12, right? 6 squared is 12? Oh, great. Okay, perfect. Okay, just checking. Just checking. All right. Again, I get 12 a lot for this one. So nice to know you guys are on top of your game this morning. Okay. Very good. So I have 1/3 pi times 36 times 15. Okay. Now, what would you do next? Charlie? What would you multiply together first? I know what I would do first, but I want to know what you guys would do first. That's what I would do first. Okay. The idea here is to leave pi for last. All right. Because you don't want a lot of decimal numbers here to have to worry about. Okay. So try to get everything else simplified as much as possible first, and then worry about pi at the very end. Okay. So what is 36 times 15? Who has that number for me? Okay, great. Lily? 530? 530? 540. Okay. That's what I was checking for. Okay. So 1/3 pi times 540, right? Okay. Now, we know then this is going to become pi times 540 over 3. Does that make sense? I just changed that 1/3 to division. Okay. So try to divide by 3 first if you can. Sometimes it might not work out to be a nice number. That's okay. All right. We're going to approximate this value anyway. What's 540 divided by 3? Go for it, Lily. 180. So this becomes 180 times pi, or you can do pi times 180 if you want to keep it in order. That's fine. Okay. All right. So now comes a big question. What do we do with pi, right? Well, in the past, what have you guys done with pi? If you guys had a pi in your calculation, how did you work with it? Monica, what did you do? You used 3.14. Okay. Anybody else use 3.14? Okay. All right. Did anybody use the pi button on their calculator before? There is a pi button on the calculator. Okay. There's also a pi button on your Desmos calculator, which is maybe the one I'm going to have you guys work with on your test next week. Okay. So we'll pop that one up probably on Thursday. Just make sure we're good with that. I want to get through these notes today, though. Okay. But there is one on your calculator. Even the calculator app, there's one on there too. I can show you where it is if you need help finding it. Okay. It is in scientific. Yes. Mm-hmm. Okay. You have to be in scientific to find it. All right. I strongly encourage you to use the pi button. However, okay, on iLearn, these are done and graded with a range of values. They take anything from 3.14 to 22 over 7, okay, as pi. Those are both approximations for pi that have been used in history, okay? And the value, actual value for pi actually falls in between there somewhere, all right? So what your answer, you have to use pi between 3.14 and 22 over 7. So I will accept 3.14, okay? But I prefer you to use the pi button to get a more accurate answer. Does that make sense? Okay. So if we were to do that, okay, let's see what we would have had. I'm going to go ahead and use Desmos for my calculator here. So I'll pull it up, and then I'm going to bring up the notes again here on the side, maybe, if it'll let me. Yeah, okay. So what we got here, pull this down here some. All right, so we're going to do 180, and then see, my pi button is right underneath the, oh, you can't see it. That's a shame. Yeah, you can. You can see it now, right? It's right there, right above that white bar, okay? The third button. Okay, so 180, and then I'm just going to type in the pi, and it's going to give me a number over here, okay? And that's going to be my final answer. I'm just going to round this off to 2 places for our class, okay? So I do 565.49. We okay with that number? 565.49? Okay. So I have 565.49 centimeters cubed. Okay? This is plug in check. This is all this is, okay? You're plugging in numbers, you're getting out a value. That's all we're doing here. Okay? It's more computation than anything else at this point. Okay, we've transitioned over. We're done with algebra for a while. Okay? Don't get excited or anything. All right. Although you guys really rocked your Pythagorean theorem assessment. You guys did a really good job. Okay. All right. Are you good with that number then? Excellent. Let's get this calculator out of the way for a minute and go on to the next example. Okay? All right. So let's take a look at this one right here. I'll take the picture. I'll take the box off. There's the picture. Get a screen cap of it. Okay. And this is probably going to be our last example today, but this will give you enough to do because you have assignment over pyramids you're going to submit tomorrow and one over cones you're going to submit tomorrow. Okay? And then we'll worry about spheres on Thursday. Okay, so study the problem for a minute and give it a go. Okay, I'll talk with you about it here in a couple of minutes. All right, or like 1.5 minutes. If it helps you to shade in your base, you can do that also. This was tilted, so it might be a little bit different looking. Okay, but if it helps you to shade in the shape, the circle shape that's your base, that's fine. Okay. Well, that's what we have to discuss. Is it the radius? Does it look like it? Uh-oh. That's a bummer. Well, so what is it? Is 6 foot a radius, everybody? It's a diameter. Uh-oh. Or, well, here's the problem. What's our formula again? Isn't it 1/3 pi r squared h, right? Well, there's not a d for diameter in my formula. Darn it. What am I going to do? How do I? Okay, so I've heard several suggestions here. Okay. My suggestion is don't change the formula because you only want to try to remember one formula for this, okay? So keep R in the formula, but can I change the diameter to a value that would be the radius? How do I do that? I divide it by 2. Very good. You guys remember that from talking about circles from a couple years ago, right? Was it last year or a couple years ago you did circles? Was it both? Good. Okay. So yeah, this was the surprise I was telling you about. Okay. Sometimes we get a little sneaky and we say diameter instead of radius. You have to watch that. Okay. If the problem says diameter or if the picture gives you a diameter, you have to change it to a radius immediately. Okay. Remember, the diameter is twice the radius. Let me write that a lot nicer. My gosh, that's horrendous. 2 equals 6. Right. So then your radius is 3. And I know I just noticed there it comes. It's a little laggy, but you'll get there. There it is. Okay. So this number goes in for the radius. Okay. And that's really the only major hiccup that I have with students working these problems. That's the big thing. They forget to substitute the radius in their formula. Okay? The math cues are really good. It's just that little step there. Okay. I'm going to let you guys finish this one now, and we'll revisit it real quickly before we start spheres on Thursday. Okay? You're dismissed. Nice work today, guys.